Now we are discussing our next topic, which is the construct AVL tree from following elements. So there are certain elements which are given to us like 64, 1, 14, 26, 13, 110, 98 and 85, and out of that we have to construct the AVL tree. We know that AVL tree is the height balance tree and it is the extension of binary search tree. And here we used to work with a formula that balancing factor should be 1, minus 1 or 0. So here we are writing the balancing factor of every node will be equal to 0, 1 or minus 1. If any node is not following this formula, then that is not the AVL tree. So construction of AVL is same as the construction of the binary search tree with this balancing factor. So now we are starting with the first element. So here we are having the first element, which is 64. So first of all we are going to place that node here, and that node is 64. So I am writing 64 here. There is a single node, that is a leaf node. So here the balancing factor of this will be 0. I am making step-by-step construction so that you can understand easily. Now we are going towards the next node. So now we are having 1. So now this one will be constructed on the left hand side of 64. So here we are having node 64, and we know that the value of 1 is lesser than 64, so it will come on the left hand side. So here 1 will come. So I am writing here 1. Once a node is constructed or inserted, then we have to again find out the balancing factor. All the leaves are having balancing factor as 0. There is only single leaf. Now find the balancing factor of 64. So here if we talk about, there on the left hand side we are having one level. On the right hand side there is no level. So 1 minus 0 is 1. So balancing factor of 64 is 1. Now check out the criteria of balancing factor. It should be 1, 0 and minus 1. So both are following. So not a problem. This is the balanced AVL. Now we are going to the next node. So here we are having 14. Now we have to construct the 14. I am taking the another step here. So talking about the 14, 14 is less than 64 but greater than 1. So 14 will come here on the right of 1. So here we are having 14. It will come here in this area. So I am writing here 14. Now is the time to find the balancing factor of this tree. All the leaves at the balancing factor 0. Then talking about balancing factor of node 1. So on the left hand side there is nothing, on the right hand side there is only one level. So 0 minus 1. So balancing factor is minus 1. Now talking about balancing factor of 64 here. There on the left hand side we are having two levels, one level and two level. So two levels are there on the left hand side. On the right hand side there is nothing. So 2 minus 0, that is 2. So here the balancing factor of node number 64 is 2. Is this a AVL tree? All the nodes should be having 0, 1 and minus 1, but here node 64 is not following the criteria, because here the balancing factor is 2 and 2 is not the criteria of balancing factor. So this is the unbalanced AVL tree. Now we know that the tree is more inclined towards the left hand side, so we want some rotation. So here we need a rotation here. Now we are trying to give the chance to 1 here, but before that we should understand that tree is more inclined towards the left hand side, and the right hand side there is no level. We know that on the left hand side there are two levels available, and the right hand side there is only 0 level. So tree will be rotated like this in that case. But for rotating the tree, we know that 64 node is not following the criteria, because right now 64 is the parent and 64 is not following the proper criteria. So now we are trying to give the opportunity to next node, which is 1. And if we construct the tree with the 1, then we will see that how it will work on. So let us suppose that 1 is the parent now. So if we talk about the 1 which is a parent, so this one is the parent here. and this is 1. Now after this one, there are two further nodes which are available, which are remaining. One is 64 and one is 14. So where they will come? If the one will take the position of 64, then obviously 64 will come down. That means 64 will come here. And we know that 64 is greater, so it will come on the right of 1. So here 64 is placed at the right of 1. Afterward, we have remaining with one node because 64 is already placed, which is 14. Now where the 14 will come? Obviously 14 is greater than 1 but less than 64. So here 14 will come on the left hand side of 64. So here on the left hand side we are going to construct it. Now this is one option. We have to find the balancing factor of this tree as well. If we perform this operation, this is not yet final. If we perform this operation, then what will be the balancing factor? We know that leaf is at 0. Now talking about node 64, here on the left we are having 1, on the right there is nothing. So 1 minus 0 is 1. Talking about node 1, so here we are having on the left hand side nothing. On the right hand side there is level 1, level 2. So two levels are there. 0 minus 2 is minus 2. Is this tree a proper AVL? If I perform this rotation, is the proper AVL? Now check out, 0 and 1 is following the criteria, no problem. But talking about minus 2, this is not following the criteria, this is not a AVL. So this rotation I cannot perform. This is the wrong option. So this type of rotation we cannot perform here. So this rotation is wrong. Now I am giving the possibility to the next child. So now here 1 is also not following the criteria. We have given the chance to 1. First the chance was given to 64, not followed. Then chance given to 1, not followed. Now is the time to give the chance to node number 14. So now we are writing the 14 here. So 14 is the parent now. After taking the chance to 14, there are two nodes remaining. One node is 64 and one is 1. If the 14 will take the position of 64, obviously then 64 will come, and we know that 64 is greater than 14. So 64 will come on the right hand side of 14. So here we are having 64 because 64 is greater than 14. Now one more element is remaining because 64 we have given. Now 1 is remaining. So this one will come on the left hand side of 14 because we know that 1 is less than 14. So here 1 is on the left hand side of 14. Now is the time to find the balancing factor. We know that all the leaf are at 0. Now talking about 14, here 1 minus 1. So on the left height is 1, right height is 1, 1 minus 1 is 0. So this is now again become the balanced AVL. So here we can now proceed. This is the proper rotation which we have made. Earlier was the wrong rotation. So in the rough work we have to check out which node will take the proper opportunity and construct the proper tree. So this is how the rotations can be made. Now is the time to construct the next element. Now we are going to the next node, which is 26. So here we are having the existing tree and we are inserting the node 26, and we know that 26 is greater than 14 but less than 64. So it will come on the left of 64. So here we are writing the 26. And this 26 is at the left of 64. Now we are going to find the balancing factor. All the leaf at the balancing factor 0. Now talking about node 64 here. So on the left we are having 1. On the right there is nothing. So 1 minus 0 is 1. Then talking about balancing factor of 14. So here on the left we are having 1. On the right we are having 1 and 2. So 1 minus 2 is minus 1. So now here all the nodes are following the balancing factor criteria because it is 0, 1 or minus 1. This is the balanced AVL, not a problem. So now we are constructing the next node here and we are inserting the element 13. So this is the 13 which we are going to insert now. So now this is the existing tree and we are going to insert the 13. We know that 13 is less than 14 and greater than 1. So 13 will come here on the right of 1. So 13 is placed here at the right of 1. Now is the time to find the balancing factor. All the leaf are having balancing factor 0. Now talking about node 64, on the left we are having 1, on the right we are having nothing. So 1 minus 0 is 1. So talking about node 1, on the left we are having nothing, on the right we are having 1 level. So 0 minus 1, the balancing factor is minus 1. Now is the time to find the balancing factor of node 14. So here on the left we are having 1 and 2, two levels are there. On the right we are having 1 and 2, two levels are there. 2 minus 2 is 0. So here all the nodes are having balancing factor 0, 1 or minus 1. So it is the proper AVL. Now is the time to construct the next node here. So the next node we are having is 1, 1, 0. This one is the existing tree and here we are inserting the node 1, 1, 0. We know that 1, 1, 0 is greater than 14, greater than 64. So here 1, 1, 0 will come on the right hand side of 64. So 1, 1, 0 is attached at the right of 64. All the leaf are on the 0. So these are the 0 level. Now the balancing factor of 64 we have to calculate. So on the left one, on the right one. So height of left is 1, height of right is 1. 1 minus 1 is 0. So 64 balancing factor is 0. Now time to find the balancing factor of node 1. Here on the left there is nothing. On the right there we are having only 1. So 0 minus 1 is minus 1. So balancing factor of 1 is minus 1. Now find the balancing factor of node 14. So here on the left we are having 1 and 2. Two levels are there. On the right we are having 1 and 2. So 2 minus 2 is 0. So 14 node also have the balancing factor 0. So all the nodes are having balancing factor 0, 1 or minus 1. This is the balanced AVL. Now we are going to construct the next node. So here the next node is 98. This one is the existing tree and here we are inserting the node 98. We know that 98 is greater than 14, greater than 64 but less than 110. So here the 98 will come on the left hand side of 110. So here the 98 is constructed at the left of 110. Now is the time to find the balancing factor. We know that all the leaf are at the 0 balancing factor. Now talking about balancing factor of 110. So here on the left we are having 1 level. On the right there is nothing. So 1 minus 0 is 1. Talking about node 64. So here on the left we are having 1 level. On the right we are having 2 levels. So 1 minus 2 is minus 1. Then talking about node 1. Here on the left we are having nothing. On the right we are having 13 means only 1 level. So 0 minus 1 is minus 1. Then talking about node 14. Here on the left we are having 1 and 2. So 2 levels are there. On the right we are having 1, 2 and 3. So 2 minus 3 is minus 1. All the nodes are either 0, 1 or minus 1 of balancing factor. This is the balanced AVL. So no problem. Now we are inserting the next node here. And the next node is 85. This is the last node of this sequence. So this one is the existing tree and here we want to insert the node 85. 85 is greater than 14, greater than 64, less than 110 and also less than 98. So 85 will come on the left hand side of 98. So here the node will be inserted on the left of 98. Now we have to find out the balancing factor of this tree. So we know that all the leaves are at the balancing factor 0. So 13, 0, 26, 0 and 85, 0. Now find the balancing factor of node 98. So here we are having only one level on the left hand side. So 1 minus 0, that is 1. Talking about 110 now, on the left we are having 1 and 2 levels are there, and right hand side there is no, so 2 minus 0 is 2. Now talking about node 64 here, on the left we are having one level, on the right hand side we are having 1, 2 and 3, so 3 levels are there, so 1 minus 3 is minus 2. Now talking about node number 1, here on the left we are having nothing, on the right we are having only one level. So 0 minus 1 is minus 1. So here we are having minus 1. Now we are going to find the balancing factor of node 14. So here on the left we are having 1 and 2. 2 height is there. On the right we are having 1, 2, 3 and 4. So here 2 minus 4 is minus 2. Now we are going to find out that whether this tree is balanced or not by finding the balancing factor. So now we have to find out whether the balancing factor is 0, 1 or minus 1 or not. If it is not, then this is not a balanced AVL. So here we can see that node 110 is having balancing factor 2, which is not following the criteria. Then again 64 node having the balancing factor minus 2, not following the criteria. Node 14 is having the balancing factor minus 2, not following the criteria. So there are 3 nodes are there which are not following the criteria of balancing factor. That's why this tree is not balanced AVL. Or we can say that it is not even an AVL, because whenever a tree is balanced, only then it is the AVL tree. So this is unbalanced AVL tree. So now here in this tree we have to apply the rotation so that unbalanced AVL become the balanced AVL. But here rotating the tree is very interesting. And it is again a question with us that there are 3 nodes which are creating the problem here. We know that the node 1 is 14, another is 64 and another is 110. 3 are the corrupted nodes, because of that a tree is unbalanced. Now should I apply the rotation on the top with the node 14 or with 64 or with 110? Because we need a subtree where the rotation need to be made. Any of the rotation we apply. But for that there is a single formula. The formula is that we have to find that corrupted node which is the main one, and with that corrupted node we will apply the rotation. Now out of these 3 we have to find one. So the formula says that we have to see the inserted node, and we know that the inserted node is node 85. So 85 is the inserted node. That means this is the last 85 node which we have inserted. After that problem comes. From this 85 we have to go from the path till the root, and we know that the root is on the top, which is 14. So 14 is our root, and talking about the inserted node which is the 85. So this one is the inserted node. So formula says that we have to go from inserted node towards the root, and we have to find out first node which is the ancestor and which is not following the balancing factor criteria. So if I talk about 98 is following the criteria because the balancing factor is 1, so no problem. Talking about node 110, their balancing factor is 2. It is not following the criteria, so this is the node which is the corrupted node, which is creating the whole problem. This is the first unbalanced node here. So from inserted nodes toward root, we will go back and check which one is the first node which is not following the balancing factor criteria, and we find that the node number 110 is the problematic node here. Now we don't have to rotate the complete tree. From this 110 till the below tree we have to rotate. So if I talk about which tree I has to rotate, then this is the only tree, or if I say the subtree, that need to be rotated, and if I rotate this tree, then the whole tree will become balanced. So only on this subtree we has to perform the rotation. So this is the subtree where the rotation need to be applied, and there we are having three nodes available, which is 110, 98 and 85. So first of all, I am constructing the remaining tree as it is. So here we have taken the tree as it is except the subtree which need to be rotated. We know that node number 110 was given the chance, but it was not following the criteria. So now we are giving the chance to next node, which is 98 here. So we are assuming that 98 is now becoming the parent. Another node will take out their specific areas. So if I write here, then 98 is now becoming the parent. So 110 location will be taken by 98. So 98 will come here. So we are inserting the 98 exactly at the position where 110 was there. So 98 is inserted at the 110 position, which is at the right of 64. So that means it is proper. 98 is greater than 64 totally. So 98 is following criteria till now. But is it the other nodes which I am placing will also follow the proper criteria? Now after giving the chance to 98, there are two nodes which are remaining, which is 110. So 110 will come on the right hand side of 98. So here I am attaching the 110 at the right of 98. Other node remaining is 85, and 85 will come at the left of 98 because 85 is less than 98. So here it is coming on the left hand side of 98. So here 110 was not following the criteria, and we have given the chance to 98 to rotate this. Now is this rotation proper? To find out that, we have to find the balancing factor of each nodes. We know that all the leaf are having the balancing factor 0. So 85, 110, 26 and 13, their balancing factor is 0. Now find out the balancing factor of 98 here. In the 98 we are having on the left one level, right one level. So 1 minus 1 is 0. Find the balancing factor of node 64. So here on the left we are having 1, on the right we are having 1 and 2. So 1 minus 2 is minus 1 balancing factor. Talking about node 1, on the left hand side we are having nothing, on the right hand side we are having 1. So 0 minus 1 is minus 1 balancing factor. Talking about node 14, on the left we are having 1 and 2. Now on the right hand side we are having 1, 2 and 3. So 3 levels are there. So 2 minus 3 is minus 1. Now all the nodes here are having balancing factor 0, 1 or minus 1. So here it is following the criteria. That means we have given the rotation that is proper and it is matching. So this is how we can construct the AVL tree with the help of different rotations and putting the elements after checking the balancing factor. So this is the final AVL tree which is properly balanced and it is constructed from the given elements. So that is all about the construction of AVL tree.